The main objective of this work is to study the fatty crack growth rate of low-carbon microalloyed steel X70 welded joints used in pipeline manufacturing. This experimental study focused on the welded joints into three different parts, namely in an affected base metal, the heat-affected zone, and the weld metal. The pipe is barely welded by submerged arc welding saw process. Fatigue cracking tests were carried out in ambient air on CT specimen. The loading frequency was 25 Hz with a sinusoidal waveform of constant amplitude of constant stress ratio in the three zones studied, like in Figure 2. The results of Figure 3 have shown that the heat-affected zone and weld metal have an important higher crack propagation resistance as the small delta chi values. The resistance to propagation of the heat-affected zone can be related to existence of acicular ferrite in microstructure. Acicular ferrite microstructure in heat-affected zone give high mechanical behavior in terms of strength and toughness. As the high values of delta chi, the affinity between cracking rates plots related for the decrease of crack closure. For low values of delta chi, this phenomenon is more marked by the crack tip plasticity following its advance, this forming a wake plasticity. For energy measurement, we noticed that the hysteretic energy Q increased when delta chi increased for the three zones studied. The energy Q is dissipated usually in plastic zone. The specific energy U decreased with delta chi at small delta chi values. Part of U is dissipated in the wake plasticity along the crack fronts to achieve a constant value at high delta chi levels. This results indicated that the specific energy depends on the microstructure and the decrease of crack closure phenomena.